Žiga's sitting on the other side of the office from me. Yeah. Žiga, welcome. The one thing you should know about Žiga is he's busy learning how to do card tricks. The one thing I would say is that I would trust his technical skills a lot more than his card trick skills at this stage. But he leads our team in Slovenia. He's a very knowledgeable man, and I've worked for him for many years, and he's become a friend rather than just a colleague or someone that I work with. So I love to listen to him speak. He's got one of those lovely accents again. So with that, without further ado, Žiga, I'm going to hand over to you, and take us away, sir.
Okay, I hope I have. Yeah, okay, it's running. So let me just find where my Zoom console is.
Yeah, for those of you just joining, just so you're aware, we had some technical issues with Ambili being able to present at this stage, so we're trying to make another plan for that and see if we can maybe get her into the schedule after this instead. But thank you, Žiga. You carry on, sir. The floor is yours.
Yeah, thank you, Roger. I think your decision about trusting my other abilities than card manage would be a safe bet. Let's just crack on. So let's talk about, in my presentation, I prepared my view of how I can see the business users who are facing the projects that would involve machine learning and in Oracle Analytics. In my practice, I have been in some situations which were quite odd, because in very often users they don't have any idea what actually needs to be done, and these are some thoughts that I gathered throughout these situations, and I would like to share this experience with you. But before I continue with my presentation, let me just start with some introductions. So as Roger has said, I'm coming from Slovenia. I'm a country manager for Qubix in Slovenia and Central Eastern Europe. By profession, I'm in IT business for almost 30 years now. I have spent the last 10, 12 years working primarily in the space of business analytics. But before that, I played many roles. I spent exactly 10 years with Oracle on several positions back in late 90s. And since then, I'm also a member of Slovenian Oracle User Group, which I'm board member for the last couple of years. Couple of years ago, I became also Oracle Ace for my contribution in Oracle Analytics. As it is usual, I would like also to say a few words about Qubix, the company that I come from. I believe that Roger has shared these slides or similar slides with you or on these occasions a couple of times, but let me just say a few words that Qubix is dedicated Oracle partner, focusing on delivering solutions in the space of ERP implementation and EPM, and also analytics. And we have started some projects in terms of data engineering, data integrations as well with our projects, product that we are also developing. Since 1987, Qubix has been engaged in about 1,000 projects, which usually happen in the countries where Qubix is based. This is today, it spans over the 4 continents and 5 countries. So besides obvious Slovenian office, we have the headquarters in the UK, and the offices in the United States, Australia, and India. And enough about Qubix, and let's move out to the let's switch to the topic that I would like to present now. So basically, the title could be also, what should a business user know about machine learning in Oracle Analytics? As I said, the reason why I'm why I prepared this presentation, and I delivered in some similar occasions before, is that we are meeting different type of users when we are on our projects. We often meet business, we also often meet some analysts, and we also meet some people who have been developing BI solutions in the past as well. And to my understanding, the use cases and business cases are primarily well known, at least by business users, whereas the content and what to expect from machine learning in some environment is not often understood. So the first thing that probably when we are talking about to business, the business usually starts with, because they don't know what to expect and they don't know what to ask. The question often comes up, can you do something and involve machine learning, something like that? And this is the hard position to start always, because if you don't have a business problem, if you don't have the question which should be answered by some machine learning algorithm, some machine learning project, then this is not a good place to start with. So the machine learning process, as it was defined about 25 years ago for data mining, it still holds as it is. And basically, I have seen this slide, this picture for quite a number of occasions. Also some Oracle's presentation included, which was quite interesting to me because I was doing my master's exactly on the topic of data preparation a decade or something, or even more some time ago. And, this slide is still live. So eventually, if you have a business problem and if you quantify it by some meaningful question, and that question can be answered by machine learning, that's a good starting point for any business user. Once this is done, then the process follows, like, and it talks about data understanding. But basically, data understanding includes much more than just understanding. It's about data collection, matching the data, combining the data, and of course, exploratory data analysis, which is one of the key cornerstones of the process. You have to understand your data. You have to know the patterns. You have to know the rules in the data in order to be able to prepare the data. The data preparation step, of course, is very important. Later, I will be talking about this topic, so I will not go into this too much, but I can say only the following. The garbage in, the garbage out. And this is so true for data preparation, machine learning in general. So if you feed the bad quality data into the data model, you can have a neural network with hundreds of hidden layers or whatever, that the model that you're going to build will not be good. So data preparation modeling, data preparation is one of the key points in the machine learning process. And this is true for any machine learning process. Then the modeling and evaluation, you will see throughout the presentation, this is rather, I would not say a commodity, but it's rather straightforward process. And by using some algorithms which produce nice models and evaluate those models automatically, you can be very productive. And of course, once you're satisfied with the quality of the models, you deploy those models. So this is the model that used to be called CRISP-DM, cross-industry standard process for data mining. And I believe this is something that every business user approaching to a machine learning project should be aware of. They don't need to know the details of it, but the process should be understood, how to tackle these things. So this is about the machine learning. Then the other thing is about machine learning in Oracle Analytics. I was planning that Ambili would present her presentation before mine, so I plan to refer to her. but now I can't, obviously. But anyway, if I had to summarize the key things about machine learning in Oracle Analytics, I would say that Oracle Analytics can support more or less complete machine learning process by effective data visualization, which gives you really good insights of the data that you are analyzing. Oracle Machine Learning includes self-service data preparation tools like data flows, which gives you ability to prepare the data for data modeling. And of course, it includes the model training and deployment tools, all in self-service mode. So it's quite fit in the self-service mode for business users. It supports both unsupervised and supervised machine learning algorithms. However, it does not support, for example, reinforcement. But in this situation, I don't think this is absolutely necessary. And what I found very useful, it has the possibility to register machine learning model that has been developed outside, and by registering, you can actually use this model and implement those models and deploy this model with Oracle Analytics. By external models at the moment, I am thinking primarily about Oracle Machine Learning for SQL or Oracle Machine Learning for Python, which runs inside Oracle database or Oracle Autonomous Database in the cloud. So this is what I see as the key features of machine learning in Oracle Analytics. But now let's turn to the typical users of Oracle Analytics, and let's try to understand what is the attitude, or I didn't find the words, but I'm using the attitude toward the machine learning in there. So as we already identify, we have business users who are the most typical users, and currently, even with Oracle Analytics, I see them still as a kind of enterprise type of users using Oracle BI type of functionality with predefined dashboarding and reporting. And by the way, you would be surprised how many pixel perfect reporting is still out there. So even though we have Oracle Analytics, business users are still leaning on this traditional way of reporting and analytics. Of course, with this hype about artificial intelligence, machine learning, the awareness of what this can do to business is much higher than in the past. So we could say that business users are pretty informed what machine learning can do to them and what are the benefits of application of machine learning application in projects using in machine learning project. On the other hand side, business users wouldn't know much about the technicalities underneath. So they would be probably very good in asking a business question, and then they will probably go along with the machine learning process, but the coding or whatever development in machine learning process would be done by somebody else. So I think this is my observation, and this is also confirming what I'm seeing on some project that we had in the past in here. On the other hand side, with Oracle Analytics, we can also see a movement of business analysts. Business analysts are the guys who are looking into more self-service space. They are looking for effective data visualization presentation. They're looking for ad hoc analytics, and they would also like to bring some other additional data sets to the table rather than just enterprise data warehouse. And this is all enabled by Oracle Analytics. So they have much more freedom than in the past, where they were limited with the quite strict development cycle with answers if they were using. So with the data analytics, data visualization family of products within Oracle Analytics, I think this is really giving them freedom to move forward. And what is interesting because these are much more advanced users than regular business users. I can see them that they are good quality, good candidate for machine learning, especially in the self-service way, which is provided by Oracle Analytics in the case. So, and because they're a little bit more technical, they can also learn, you know, what machine learning is from a technical point of view, how it works, and they can also use, you know, the information provided by machine learning models to understand the result, the quality, and such. So I see business analysts quite important part of the story when business users will be or are asking for some solutions. Interesting enough, I'm not including developers and administrators in terms of BI development, you know, the traditional ones. Over the last couple of years, I have been delivering quite a lot of business Oracle Analytics trainings. And before Oracle Analytics, there was business intelligence cloud service trainings in EMEA for EMEA and partners. And, you know, the topic that was the hardest part of the training was machine learning. Traditional BI developers and administrators, they don't have much information about the machine learning. So it's these things are completely new, and sometimes they even struggle with the functionality available out of the box. That's my experience. I don't know, maybe yours is slightly different, but you know, if I had to draw a median line, that would be placed. But on the other hand side, you know, with the data scientists are the most natural users of machine learning. So the question would be, you know, where the data scientists fit in this story with Oracle Analytics. And my belief is actually they are not very enthusiastic about the features and functions available at the moment in Oracle Analytics, and they would not choose the Oracle Analytics as a tool of choice for data science. So that's definitely something that could be a problem. But because Oracle Analytics tends to be open for additional models that are developed outside, this actually is not a big problem for the data scientist to develop his or her own machine learning model in Oracle machine learning environment. And as I understand, this is going to extend, and it will cover also the data science cloud service in the future. So basically, you know, full stack of you know, machine learning in Python will be covered in the not so distant future within Oracle Analytics. That's basically good news. So what I can see, and basically all of us who are working with these tools that I already mentioned so far, is about the trade-off. Yeah? If a business user is looking for fast solutions, maybe not the best, or let's call them good enough machine learning models, then the features and functionality within Oracle Analytics can to a certain degree fulfill all the requirements. And this can be done much faster than the regular machine learning cycle that would be done by somebody like a data scientist, you know, who is actually looking for the best model there is. So the trade-off for the business user is somewhere in this line between the simplicity of the models and the duration of the project in one side, and the accuracy or any other observed metrics on the other hand side. So, and this is something that they could play on. But you know, sometimes the tools inside available also dictate this trade-off as well. Let me just share an example that happened to me a couple of weeks ago or months. We have a retail customer who is a retail chain with about 600 stores. And, you know, when we started to talk, you know, we are, you know, running a big data warehousing project there. And, you know, at one point of time, they came to us and they said, okay, we would like to see, you know, can we do something like, you know, it ended up like market basket analysis, you know, one of the, you know, the basic machine learning things that you can do in the retail. So which products are more often sold together? Can we use this information for some upsell and cross-sell? And by the way, Oracle Analytics out of the box support this type of solution. You don't need to be a data scientist to solve this problem. So you will see later in presentation, data flows can be used. The data can be, prepared. You just need, two main attributes like transaction ID and product ID, and then there you go. So it's rather straightforward, and it runs quite well. But once they got these first results, they saw, okay, these bags are sold with that fruits, and these bananas are sold with I don't know what, with beer, I don't know. They started to think, this is not enough for us, So the question just started to emerge, and the question like this came along, and they also found this nice visualization somewhere on the internet, how somebody resolved the this nice visualization. So what they said is actually, can you provide analysis that will analyze each and every store by period of the day band, like morning, midday, afternoon, evening, and present this by store. So suddenly we have a problem, at least in Oracle Analytics, because there is no easy way to run 600 stores 4 times in a loop to get 2,500 or so machine learning models. And this is the point where there is no trade-off. Oracle machine learning actually gives you the solution, and which is really nice. I'm really fond of it, because you can run several instances of machine learning models and train several instances of machine learning models simultaneously by using the model partitioning option when you're running a machine learning algorithm. And this can be done relatively easy. And what I was really surprised of, I'm working, for example, on a data set of about 150 million rows for about a month or something like that. And this is executed in a matter of a couple of minutes. A really effective way of applying something gradually into the system. Okay, so let's assume that we understand our business problem and that we would like to proceed with machine learning project. Again, typical situation. We are talking to business and we are explaining that we need to prepare the data in order to set up, create and train a machine learning model, and so on and so forth. And the answer from the other side says, oh, okay, don't worry, because we already have everything ready. We have this nice data warehouse. We spent I don't know how much time to really clean it up, and this is operational reporting or whatever analytics comes out of it. And deal done, right? Well, from the data scientist perspective, or even business user who is trying to implement machine learning into processes, this is no way forward. Data warehouse is not the data source. I mean, it can be a data source, but it cannot be used for machine learning, even though Oracle machine learning allows you also to deal with nested tables, for example. But okay, I mean, this is not way forward. And the data discovery, data preparation, as I said a couple of times, and I probably will repeat myself even more often, is really crucial for the success of the project. There are just a couple of facts I would like to share with you. The first one is that data preparation might take up to 90% of all machine learning project time. So it's really important that you do it well. And when you're doing well, you will get data quality data. The quality data counts, again, 75 to 90% of overall machine learning success. So I don't think I can emphasize enough that everyone doing machine learning should be aware of the fact that the data must be prepared at the level that is expected. If the data is not prepared properly, then anyone who is using this might face some issues at the end. Okay, so let's take a look what options have we got if we are using data Oracle Analytics. So Oracle Analytics comes with a set of data visualization options and tools, and quite a lot of them can be used for this exploratory data analysis. There's option to by a couple of clicks, you can set up correlation metrics like an example above. You can use the trend line on the scatter graph to see the correlation among the 2 or 3 different attributes. You can use the special graphs like box plot, which will give you the anomalies in the data sets like outliers and these sort of things. You can deploy segments, and I mean, you can use clusters out of the box and these sort of things, which don't require any specific coding upfront and so on. Additionally, you could business users or analysts, using these tools can use the explain and auto insight functions, which are also quite interesting, especially explain, which basically gives you a lot of insights about the data sets and the correlations that between one specific attribute has against other attributes. It can show you if there are any anomalies and things like that. So there are a lot of information that can be gathered just by visualizing and running these specific algorithms like explain or auto insight. Of course, on the other hand side, exploratory data analysis by somebody as a data scientist using Zeppelin notebooks can be a little bit more detailed and thorough. So SQL, PL SQL, Python programming language can be effectively used for analysis, for data wrangling, whatever sort that is required. What is also interesting, I mean, this is not available in Oracle Analytics. For example, SQL statistical functions, let's say t-test or chi-square functions. These are not available, but they can be used when you're looking into the data in really detailed as a data science and analyzing the dependencies in the data. And by using Zeppelin notebook, you can still visualize some data as it is example on this graph. Of course, it's not the level that you would get on Oracle Analytics, but still you can use the visualization there. Things to consider when you're preparing the data. As I said, data warehouse structure like star schema, snowflake schema, or even third normal form of the transactional databases, they cannot be used with machine learning algorithms. All the data that we would like to feed the algorithm with have to be presented in the flat format, which is highly denormalized structure, and that's kind of structure should be prepared the way that, for example, if you're doing some churn management, churn prediction, that each customer has exactly one row in this data set. This is the target that every one who is preparing the data, including business analysts using data flows, should aim for. Of course, data scientists will also take that into consideration. Things to consider, not necessary that we need to do a lot of things about, but still, the quality data is measured by things like missing values or outlier values, by how the data, the numerical values are normalized or not normalized, how you can handle the categorical values in when you're applying certain algorithms, like linear regression requires just numerical values, and you have to handle those categorical values there. You have to deal with correlations in data. And at the end of the day, you will probably, or I mean, business user will have to do some transformations. Like I had an example where there was marketing campaign for selling some books, kids books, and the data was the date of birth of their parents, which is a nice information if you've got, but I think better information is age. But this is something that can be discussed. Why I said that these things are things to consider, but maybe don't worry too much about them, is that algorithms, even with Oracle Analytics, and also we can see the same pattern in Oracle Machine Learning, can handle some of these issues automatically if we provide some input information. So this would look like this. A business analyst would build a data flow in Oracle Analytics, and there is the second step will be train a model, like train regression for model, train the model for linear regression, and there are some predefined fields when you're defining this particular step, which basically handle these things. So you can have this imputation, which will resolve missing values issue. You can change the categorical value into some numerical value, and you can also standardize data in order to bring all the numerical values in the range between 0 and 1. Of course, users are usually not aware what kind of transformations are happening, for example, for transformation, or they are just offer a couple of options like mean, median, maximum, minimum value, and something like that. When doing machine learning data preparation, experienced machine learning the data scientists would, for example, for standardization, consider not only the basic functions as we have in the line first or the second line, min-max transformation, but maybe they would go for some really sophisticated sigmoid function, which is listed down below. Why is this important? Because you're building on a data set that is a training data set, and the training data set might have minimum and maximum value. And all the values will be, transferred by these values. But, the new data set that comes will also contain the values that will need to be normalized or standardized. And what will happen with the algorithm if there are higher values than the maximum value in the new data set? Because in that case, the value that will be transferred will be about 1. So these are the things that, nobody can tell now exactly what will happen with the algorithm in the next step. But, these are the things that not necessarily will have to be implemented, but sometimes we have to be careful and be aware of when we are preparing our machine learning models. Or these are the points where machine learning models that were created using Oracle Analytics can be improved. The second example would be how to replace a missing value. Again, some of algorithms will just ignore this particular row with the missing value in there. The problem with that, if this line is ignored, important information might be lost. So every data scientist, and in case of Oracle Analytics, even there, at least some value has to be replaced, be used to replace this particular missing value. But of course, we might see a number of choices there again. You saw in the screenshot from the previous slide that the mean value was selected. But, is mean value the best value we can choose to replace the value? And, some might argue, why don't we choose the most probable value? Or maybe why don't we choose a value that doesn't change the variance of the particular feature? So these are the questions that data scientists will probably address during this data preparation. And as I said, not necessarily this will be, the concern of the business user or even business analyst, but still, this could be a problem if this is not handled properly. And something that is straightforward, highly correlated data columns might affect the predictions. So when we are preparing data sets for machine learning, we need to make sure that these high correlations are taken out of equation. Otherwise, this highly correlated could have strong effect on the prediction. So a nice tool in Oracle Analytics is called data flows, which basically without any coding, simply a step would enable users to take that out. So these are a couple of things that I wanted to share with you when you're dealing, or business users, business analysts are looking at data preparation. Of course, data scientists, beside everything already said, will go even deeper and will use SQL and Python for data preparation, for all the transformation. He or she might be very effective in this because he's using the database and all the features there. As you can see on example on the right, there are also fine-grained controls over the in-algorithm data preparations. So you can set these settings and you can have auto preparation on all the time, so you don't have to worry much about. And there might be some other data preparation challenges that need to be dealt with, like data sampling, dimensionality reductions, and so on. I don't want to go into that area. So once the data is prepared,
Žiga, just because we sort of started off time and stuff, just to give you a schedule, you've got about 8 minutes left of chat.
Yeah, I think I'm on schedule. So thank you, Roger.
Sure.
So the training part, which follows in Oracle Analytics is very straightforward. It's a data flow that you have to create. You have to apply the model training step, which can be one of those machine learning algorithms, and that's basically it. What else needs to be done? There are some parameters, very limited, that you have to set. It's self-service, and this is basically it. What is nice thing about it? If you specify the percentage of the train test split, you will the evaluation will be done automatically. So instantly, once the model is created, you can take a look at the quality metrics like precisions and accuracy and other metrics. And by the way, there will be additional data sets also created for better explainability of what has happened. And this is basically what the user has to know in terms of that. Of course, on the other hand side, data scientists in Oracle database will use all the features available of the database. SQL is the best with the data handling. And here is just an example of the model creation for the association rules model I mentioned before. Here, the partitioning, you can specify how you would like to partition your big data set of 150 rows, and you expect, for example, 3,000 partitions to be created. So again, much more detailed and more specific data modeling and such. As I said, scoring in Oracle Analytics is done automatically. You can get, for example, confusion matrix out of the box. You just have to navigate yourself to the quality tab in inspect, model inspect window. You get all the metrics like F1, model accuracy, precision, we call calculated. If you would like to see the lift and gain functions, there's a little bit additional step required, but it's really, again, out of the box. It's another data flow which will generate this required information, which can be now then visualized, and you can instantly see which model should be used. In this case, I'm looking at neural network and random forest, and it seems neural network is slightly better than the random forest, and I would then pick the neural network for further deployment. Similar thing also happens in a database. A little bit more coding is required, but data scientists might exploit whatever is generated within model training model training. There is, as a result of that model training, there are a number of database tables and database views, which gives you more insights about the quality of the of a particular model. Similar thing can be done either in SQL or using Python. Once the model is created in Oracle Analytics, it's instantly deployable. Deployment would go two-way, and I will get back in next slide. If there was a data scientist creating that model in a database, then the model has to be registered with Oracle Analytics first, and then all the steps are the same regardless where the generated model comes from. So if I just take a look how you can deploy the model, as I said, additional data flow can be created with 3 steps. The first step will be the new data set that you would like to predict on. Then the apply model step, which defines what machine learning model is applied, and save data is the data set with the predicted information, and that can be then used in a new workbook for further analysis. Alternative approach would be that you don't create a data flow, but you just start creating a new workbook with the new data, with the data set, or with the new data set, and use something that is called scenario, which will cause that you can run the machine learning algorithm on the fly as the data is presented on the canvas. So these are the 2 options of application, and the final result at the end might look like this. So here are some examples. So data visualization features of Oracle Analytics are really powerful, and instead of reviewing some boring tables or something like that, you can actually visualize the result as once this exercise is completed. Okay, so what's next? Just one slide and then I'm finished. So in Oracle Machine Learning, we already have something that is called Automated Machine Learning Feature, AutoML, which basically automates the most not more time consuming, but quite intense steps of the machine learning process, which are part of the data preparation, the complete modeling and evaluation cycle. So using automated machine learning, we can come up with the best model by reviewing a range of different algorithms with a range of high parameter settings. And at the end, this is fully automated process that gives you the algorithms and the settings in some order, and you can come up with some best model, and that model can be then fed back to the Oracle Analytics. What I have heard is that this is also to be expected in some near future in Oracle Analytics, and this might be quite interesting to cope with, you know, when business users are trying to embrace machine learning and use machine learning on a daily level. So let me just finish with a couple of final thoughts, which might be relevant to a business user deciding to go for machine learning. So first of all, Oracle Analytics supports the full cycle of machine learning process. Of course, the end results are good enough machine learning models, and for better, Oracle Machine Learning in the database is more likely to be used. We have witnessed that business users are quite often prepared to compensate the speed of development with some accuracy of predictions. So if the accuracy is 92% instead of 94%, who cares? They can proceed with the business problem resolution, because sometimes time is more important than those 2 additional percent to get the best result. I think automated machine learning will bring machine learning in Oracle Analytics much closer to business users, business analysts, and of course this will not be something really enthusiastic for data scientists, but the finding the best model from good enough model can be achieved by that. But don't forget, data still needs to be properly prepared, collected, analyzed, and of course, the right question has to be asked. So having said that, I think I spent those 8 minutes, as promised,
Yeah.
here is my closure for the presentation. And if there are any questions, I would be glad to answer. Or if anyone wants to take that offline, I'm also available. Thank you for listening.
Thank you very much, Žiga. That was spot on the time. There are no formal questions, but I did have one, which I always like to throw something at you just to keep you on your toes. But you did talk about how the ML is getting more and more fully featured, within the Oracle toolset, and I guess, and you then talked about when the data scientists would need to step in. Do you think, as a technician, that the point at which the data scientist now needs to step in is getting further and further back, or is it something? Or is it? Do you have a different feeling about that? And I say that with trepidation because I know that we've got some data scientists on the line.
Yeah, I mean, I think, I could be completely wrong here, but in a way, machine learning is becoming kind of a commodity, isn't it? If we neglect the data preparation part, actually, with automated machine learning, the requirement for data scientists might be, they might not be even in the picture. So this is a kind of worrying for me, because I really like this type of things. On the other hand side, I think with the advancements of the technology, like for example, if for example, let's say Oracle machine learning is based in Oracle database is based on what was available in Oracle Oracle database for years, from the data mining times and so on and so forth. Of course, things are getting improved and so on. But on the other hand side, development of machine learning and, tools and the frameworks are expanding. For example, if there is an announcement that, there's an expectation that, for example, data science cloud could be, used for the data modeling for Oracle Analytics, then, you suddenly open something that is quite popular with data science nowadays, like TensorFlow, Keras, and other, are suddenly available in this Oracle Analytics environment as well. And I think this can improve the models even further.
Yeah.
So yeah, I think in one way, data scientists are a little bit pushed back, but on the other hand side, there's a huge field opening for them, and working on some other stuff than just predicting who will respond to a marketing campaign, right?
Yeah. Well, Žiga, thank you. All that remains for me to do is to say thanks. I really enjoyed the presentation. We appreciate you sharing it with us. And I think from there, as we say goodbye to Žiga, we're going to